So I would like to introduce myself. My name is Anna Sundukova. I am just starting my way in IT. So I'm a junior software developer, currently working in Accenture. And actually I had this great opportunity, how the story began with this presentation, that I get this great opportunity to actually participate conference called DevOps this summer. And of course, when you participate something, there's something expected from you. So there was expected some interesting topic I would like to share with my colleagues. So I would like to share also with the members of DevClub. So here I am. And let's start from the beginning. One moment, I think I have some. Yeah. So let's start from the beginning. So let's start with the cause. And the cause is Wi-Fi. So probably I don't need to introduce to you this technology, right? Everyone is using it, and everyone is aware that it's a way how we connect to the internet without using cables. And the most important that I would need to mention that you take into consideration that it's using radio signals for its communication, right? So, and then probably you would say, okay, but what's wrong with Wi-Fi? It has even penetrated in our Maslow pyramid, and it's like some people are not even shy to say that it's the most important amenity for them. Or some are saying they're getting even grumpier without Wi-Fi than without a cup of coffee. So we can see that it's used really a lot. And the thing is, the more it is used, actually, the more problems we start to have in the way that it's being too crowded. So probably all of you are aware that there exists this thing that's called Internet of Things. So everything and everyone needs or wants to be connected. So actually, Internet of Things has become one of the most hyped and probably most important expressions across today's business world, right? So we are prognosed to have billions of devices connected in the future, but I think that we are already in the future. So, and where the problem appear, maybe you would ask, and I could answer it with this question. So how do you think, is there a limit for data or connectivity? I mean, as you can see in this image, right? And the answer is yes, actually, there is a limit for it. And we probably, most of us have sometimes experienced this irritating feeling where the connection is very slow, it's disappearing, or more and more devices actually compete for the same piece of bandwidth. So it already causes some clashes of signals. And it is like promised that it's going to be just getting worse. So yeah, I mentioned this word bandwidth. Maybe you are not familiar with it. So I would like to introduce you this radio frequency spectrum. In other words, it's electromagnetic framework, which is divided in these bandwidths, and they are different by their like strength, the low frequency, middle, high frequency. And just to give you a simple example of like a life situation from the real life, imagine you're driving a car and you are in between two radio towers. So you're listening your favorite song, and at one point it goes like, and just like interrupts your great feeling. So what happens in this place is that those radio waves actually interfered each other. They had a clash, and most probably they were on the same frequency. So how do we fight this? It's usually by isolation. So the isolation can happen geographically, or it can happen by different frequency. So For example, if you take a look at all those little squares, those are called spectrums. And I don't know, maybe you wouldn't believe it, it's actually like ridiculously drawn by hand and measured millimeter by millimeter. And this is not the joke written there, it's actually the most hotly contested bits of real estate today. And they're invisible. So it's almost impossible for you to get inside there. And in the same time, it is too slow to adapt for new technologies. So, I'm sorry. So what would be the solution for it? There's this one organization called DARPA, and they're like talking about using artificial intelligence and machine learning and make those spectrums smart. So for example, as Wi-Fi is mainly based in 2.55 gigahertz bandwidth, so there, as it's the most crowded, there you would have those spectrums like communicating with each other. And for example, if I have a radio station and it goes live twice a week, so the rest of the time is free. So this smart communication would allow this free time being used by another user. Yeah, but that's the DARPA solution for this problem. And if you would say me, okay, but that's not really, big problem, right? Because if I just lose my favorite song in the car or something, but imagine if this clash happens in the factory where you have a whirling machine and robots on the floor. So the radio waves just clash with each other and the connection is dropped or really bad. So my solution, it's not mine, unfortunately, but yeah, the solution I would like to introduce you is not very similar to DARPA's solution. So it's actually completely going away from radio waves and using another medium, and this medium is light. So there is actually this technology which already was introduced few years ago. I think something like 10 years ago it came public, and it's called LiFi. So it's kind of web delivered by light. So probably you will just, if you're not familiar with this technology, maybe you will get afraid and will say, oh my God, it's going to substitute Wi-Fi. But okay, let's not jump so far in the beginning. Let's go slowly, step by step. So it's actually coined by Harald Haas, and he was going live with it in year 2011 in a TED Talk. He actually showed how does it work, and it was introduced as a transmitting data via light, via imperceptible flickering of light. And it is like a Morse code, when you were sending these kind of messages, but it's just by light. So, and it's happening so fast that it's invisible to human eye. And what is LiFi? So LiFi is a high-speed bidirectional wireless communication which uses visible part of the light. Actually, it can use also infrared light. And it offers similar experience as traditional wireless communication. Just instead of radio frequency, which is like having these crashes and interferences, it's using a light spectrum. So the data is transported by the light, and it is encoded in subtle changes of brightness, and in this way reaching incredible speed and security. So maybe now you will come up with the question, okay, but it's just a light. I mean, we have it for already centuries, right? Or something like that for many years. And why wouldn't we come up with something like that before? So the question is that it's not just a light, it's actually LED light. So, and why LED light? Because it has this amazing property that you can switch it on and off for like 1 million times per second. I mean, probably not with your finger, right? Don't try to repeat this speed. Yeah, but I mean, that's a possibility. And just because of this property, it actually allows you to implement this technology, which can perform in such a, incredible way. So how does it actually work? So LiFi uses light as a medium for a transmission of data, and it requires two components, a photodiode and a light source. The photodiode acts like a transceiver that receives light signal and transmits them back. The light source transmits data. The light source which transmits data is outfitted with a little chip, so it serves as the signal processing unit. When I say it requires two components, and here you see, like in this example, you see actually three components, it's just because this is like a future vision. It's still not implemented in the commercial gadgets. So now it actually just works with a dongle, like a USB stick. So there you have the receiver and transmitter. Both of them are in the same place. So yeah, this leads to that LED light bulb actually serves as a semiconductor. And this means current supplied to the bulb can be modulated, which in turn modulates the light they emit. And this process occurs at so extremely high speed that it is unperceivable to human eye. So data is fed into the light bulb, it sends the data to the photodiode, and it converts the data into the binary data stream, so it's perceivable by our gadgets. I'm aware of that sometimes when someone is explaining something just like verbally, it's a bit hard to understand. So I also always like to see things visually. So I would like to offer you to watch now a little video. And this video is actually accessible on YouTube. It's made by Pure LiFi, one of the leading companies in LiFi technologies now. So all credits for the video goes for Pure LiFi. So let me share it now. Yes, one moment. Here we go.
Imagine a world where light becomes data. LiFi is simple but powerful. We all know how a light bulb works. When an electrical current is applied to an LED light bulb, a constant stream of light is emitted from the bulb, which we see as illumination. Since LED bulbs are electronic devices, the current and therefore the light can be modulated at extremely high speeds. This can be detected by a photodetector and converted back to electrical current, therefore carrying data. This is the nervous system of an internet revolution. LiFi doesn't replace your internet service provider. You'll still need them to get the internet to your home or office via wires. However, once you have that high-speed connection, you can deploy your fast, secure LiFi network using power over Ethernet or powerline communications. LiFi offers greater density than many other radio frequency solutions. For example, if you have an average Wi-Fi router in your office that provides up to 100 megabits per second and 15 people are connected to that router, it means that you might only be able to access 4 megabits per second. However, with a LiFi network of lights that offer 42 megabits per light, even if you had only 8 lights in your room, those same 15 people could share more than 300 megabits per second. That's dense and fast wireless communication. Real LiFi is also bidirectional, full duplex, and high speed. Data is transmitted and received at the same time, resulting in a really fast, reliable user experience, especially when doing things like Skype calls, video streaming, and virtual reality. Real LiFi is fully networked. That means all the lights in your LiFi network can speak to each other and hand over as you move around the space. Each light even has its own IP address, which means that you can offer location tracking and geofencing within your network. LiFi, a world with unprecedented data and bandwidth. Be part of the light revolution.
Yeah, so thank you, Pure LiFi, for helping make it more visual. So let's continue. So now I guess you're completely aware what are the biggest differences between Wi-Fi and LiFi, right? So actually LiFi is using light spectrum, so its capacity is immense. because it is not like so crowded as we were just taking a look in the bandwidth of radio waves. It is transmitting data via light fixtures. It has no disruption to interference due to interference, and its signal cannot pass a physical barrier. Actually, that thing is this offers this incredible feature of security, but in the same time, it's kind of considered also as a weakness because it's more limited. So potentially it has a very large coverage, but radius is limited by the line of sight. And the speed could be 100 times faster than Wi-Fi, and data density is much greater. So you would be able to support an influx of IoT devices. That wouldn't be any problem there. So, but for now, it still lacks infrastructure for mass implementation. Yeah, there is another meaningful vision which I came across while I was investigating this subject, and I found it very interesting, so I want to share it with you. There is the scientist Sua Topsu, and he actually is a founder of one of the leading companies of LiFi technology now. It's called OLED.com. And it was a very interesting story. It was actually a funny story from his private life, how he came across this technology and started to be involved. So he shared the story in one of the interviews. So it was his wife who came to him, and she unplugged the Wi-Fi router, and she said, you know, this radiomagnetics electromagnetic radiation is dangerous for us, so we cannot keep it like on all the time. It's not doing us any good. So yeah, so he said, okay, I will gonna prove you something that it's not true, you know. So he was reading and researching a lot, but at the end he came up that there is nothing that could like stand against the information which was delivered by his wife. So he started to look into some other ways how the connectivity could still be wireless but without using radio waves. So that's when he came across the LiFi technology, and he got really involved in that. But the interesting thing, which actually caused my attention a lot, was that his like attitude towards it. So he was telling himself, I'm definitely supporting technology that has an impact. So not just that LiFi is something new, innovative and cool, but no, it actually has a really huge impact. So it is much more environmentally friendly, and it also more health safe, let's say like this. So why? And he gives a lot of examples. He actually compares it more with 5G. So as he mentions, 5G also requires many things to be implemented. It's appearing slowly also in Latvia, right? But it requires 10 times more antennas. Those antennas are having 10 times bigger consumption than, for example, 4G antennas. And this also forces countries to pass their allowed limit for radio waves. For example, one of the examples, the strictest country there is, Switzerland, strictest, I mean, towards the most strict country towards that, their like limitations for electromagnetic radiation. And it was like 0.6 volts per meter. So after implementing 5G, they needed to change it to 60 volts per meter. So the difference is like 100 times. And I mean, just by saying those numbers, you kind of understand why people are like misunderstanding and making a buzz about it. So, and then another difference of 5G, if we compare to 4G, for example, it's that it starts to use 3 different bandwidths, as we were checking before, this map of spectrums. So it actually, besides low band and mid band, which was the most used and the most crowded, it starts to use high band, which has like a stronger radiation because it's using millimeter waves in their communication. But I mean, we are already familiar with millimeter waves because they are already used in airports. For example, if you travel to United States, you have those boxes where they scan you that you have no weapons on your body, and so those are not killing us. Yeah, but the thing is, there's a bit lack of the study how those millimeter waves actually would like affect us when we are disposed for a long time. So yeah, there is a bit like not enough studies towards this. So that's why Suatopso is actually saying, okay, if we want 5th generation connectivity, we can have it, but let's use light. And he says LiFi is now at its most strategic point, and the timing is right, but he also mentions that it's never fast to implement something new. Yeah, so it takes time. You're not alone in the market. You need to educate partners and people. So many of representatives of LiFi technology are saying there are many advantages if only gadget and laptop makers would get behind it. So it's not so fast to implement it. And yeah, it's actually considered that there are 5G challenges that LiFi solves. We already covered the spectrum. So LiFi has unlimited spectrum of light, and it's like 10,000 times bigger than the radio frequency spectrum. So its capacity is immense. And lower cost because a lot of infrastructure is already there. We have light everywhere if you compare with 5G, which requires a lot of implementation of new antennas. So faster time to market and coverage is present everywhere. Yeah, but then we come to the point where, as usual, like, I mean, in the real world, nothing is really black or nothing is really, really white. So I will not say, and it's also not considered for now that one will replace another one. Actually, for now, they will work as a really great team. LiFi and Wi-Fi both have awesome advantages. So by combining both of those technologies, it could lead to very, very good results and much better solutions. So for example, imagine that you can set up a room that is designed with a high security and with its own LiFi network, which no one can connect to, and the isolation, as the light does not travel through walls. So the buildings are kind of impenetrable. So you cannot have a hacker outside the wall who is just connecting to your network. And for example, inside in a building, you have some vulnerable IoT device that is connected, and the information is very important. So, but despite of all the good things, there's still a number of limitations that LiFi is sending. So, for example, it is still affected by very bright light, for example, in outside. So, it's also considered that LiFi connectivity will not appear anytime soon outside. So probably most adopters will probably employ LiFi bulbs in one or another room, and then in addition, they will still use Wi-Fi as well, at least for the beginning of time. So, and if we take a look at LiFi opportunities, there are actually its ends. So connectivity we already covered, and Internet of Things. So someone actually needs to bring this data from all devices to the internet, because I mean, nowadays even a toothbrush which you are using is sending some kind of information what happens in your mouth, right? So and as Wi-Fi is kind of starts to fail a bit because of this connectivity, so LiFi has this great opportunity to show how good it can work in this place. So it's like internet of everything, right? Also, telecom street lamps, they already can be used for implementing LiFi there as well. And then there are those niche industries which are not even covered by, they're not even covered by Wi-Fi because there are places which, due to safety and operational reasons, you cannot implement Wi-Fi there. For example, planes, hospitals, or even in France, there are some schools which are not very keen to use Wi-Fi, or some power plants. So actually there, LiFi is like all doors open, and they're already being tests made by some airplanes and hospitals, and they're being implemented and tested. How does it work? Then where is LiFi right now? So just a few months ago, it actually made its first ever large-scale deployment, and it was multi-million-dollar deal with U.S. Army. So it's known for everyone, right? That first, all the things all technologies are tested by the Army, or they're used first by Army, and only then it appears for ordinary people. So actually, this kind of proves how evaluated is this security property which LiFi is carrying. So everyone is aware, right, that the Wi-Fi networks are still vulnerable to different forms of attacks. For example, you can crack the password of the network, and yeah. So LiFi connection, it actually just takes place in areas that light can touch. So it guarantees reduced leakage and localized coverage as well. And actually each light, as we also saw as we were watching in the video, can create different network zones. So it considered really, really secure. Even the interesting part is that it's not just like replacing something and being more secure. It actually creates a lot of opportunities for creative security solutions. For example, assigning specific access point means that you can be monitored at every mobile device, can be localized and tracked. For example, you enter the White House and you have your mobile device, right, connected, and then you're passing the lights and you need to go from the door to the hall, which is in the end of the building. So actually by connecting with each of light, you will be traceable, right? And also there's another idea that, for example, you can, before you connect to the conference room, you need to be able to connect to the neighboring area. So it's kind of creates an extra layer of security. So yeah, it's LiFi is considered very, very, very good towards the security of protection. So let's take a look a little bit to statistics. And of course, the market is growing. In 2020, it was valued by $213 million. The biggest market share for now belongs to United States, and the market is still fairly fragmented with numerous players, but it's definitely get more crowded and more people will go inside in it. So key drivers, of course, are increasing demand for high-speed network and highly secure network. And if we take a look at some forecasts, so as I mentioned before, those niche industries where Wi-Fi is not present, even because of this security reasons. So healthcare, aerospace, transportation, the government towards the safety or healthcare data, and also retail. Retail will be booming. It's forecasted. So why? Because retail, when you enter the store, it's full of lights. So actually each light can be a connection point. So it's like a navigation systems or many other ideas you can implement by using LiFi. So the regional share of LiFi market, as I mentioned before, the biggest share goes to United States and Europe, and others are considered as a futuristic markets yet. And what's next? Yeah, so actually, it's very interesting to notice that LiFi is not just replacing Wi-Fi and working maybe more efficiently. No, it's actually, it's so interesting to see that this technology is causing so many innovations. For example, there's this one company in Australia which are offering underwater communication system, or for example, quantum LiFi technology, having some encryption products, etc. Yeah. So, and also from the point of view of Accenture, LiFi is actually very interesting for its security consideration, environmental impact, speed, and accessibility. So existing 5G implementation should not be taken as granted. If there are also other approaches, maybe the mix of them is leading to better solution. So there's also from side of Accenture, there is a big interest to take a deeper look and understand how LiFi works. And maybe if everything goes well, maybe we'll create also some prototypes here in Latvia. Yeah, and as I mentioned, environmental impact, but I didn't talk much about it. But if you just consider that LED by itself is consuming less energy, or for example, the LED light bulb is now like working for two things, not just like illuminating you, it's also sending you data. Or there are even some projects where the transformer of light to data stream is built in a solar panel. So actually the light which comes out of the LED actually accumulates energy in the solar panel. So there are many interesting things. So I highly suggest you to follow the progress of this technology. And I strongly believe that this is going to move to era of digital light. So let's be part of it. Thank you for your attention. I hope it was interesting. Maybe you learned something new. Are there any questions?